Welcome back, everybody. We're going to be looking at numbers 47 through 50. I was doing 56 and I kept getting a mistake here, so I apologize for that. I'll have a better explanation for that later. But it is important for us to relate the volumes of, of the lobsters, so their lengths cubed to their weights, as well as the crawfish. So we're going to be dealing with a cubic proportionality there. Let's take a look at 47. Hakeem measured an oven's temperature at set points from 50 degrees Fahrenheit to 300 degrees Fahrenheit in 50-degree increments. The actual oven temperatures measured with a thermometer were 55, 112, so on and so forth, respectively. And they want us to find out if a cake is supposed to be baked, so this is the temperature inside the oven. So that's going to be our Y values in this case, because we set the temperature on the oven, but the actual temperature is what we are recording, and so that's going to be dependent on our set point. And they want us to find out what should the oven set point be. So in this case, we start out 55 enter, 50 sigma plus, 112 enter, 100 sigma plus, 175 enter, 150 sigma plus, so on and so forth. And after you're done adding all those entries into the stat register, you type in 350 and you push the linear regression analysis button. And then you're going to solve for x. You're going to go to, hey, what is the x value that corresponds with this y? For 48, we throw that into the solver. Let's go ahead and look at number 49 now. A cylinder with a conical cavity. They give us the diameter of the cylinder, they give us the height of the cylinder, and they want us to find the height of the cone, and they give us the volume as well. Well, while we may not have a specific formula for the shape or the volume of this shape, we can build it up. It's going to be the total volume of the cylinder minus the volume of the cone. And the volume of the cylinder is going to be its base area, which is pi r squared. So we take 2.79, cut that in half. We're going to square it, multiply by pi. And then we take that area and extrude it or multiply by the perpendicular distance of 4.26. From there, we're going to subtract the volume of a cone. The volume of a cone is 1/3 the base area times its height. So 1/3 times 2.97 over 2 squared times height. And from here, you can either turn it into a cruncher or throw it into the solver. But those two equations subtracted equal 24.8. Let's go to number 50. 50 looks a little intimidating, and we need to relate a couple of things here to be able to get our answer quickly. We happen to have a sphere, and it's going to have a cubical cavity whose corners are in contact with the sphere. So the important thing is, because the corner is in contact with the sphere, it is at the edge of the sphere. And so the distance from the corner to the center of the cube or the center of the circle, that's going to be this diagonal cut in half. So the radius is half of the 3D diagonal. And we've been mentioning this before, that the 3D diagonal is going to be square root of 3, or square root of the dimension, times the side length. And they want us to find the side length. So we're going to want to write this diagonal in terms of the side length. So it's going to be square root of 3 over 2 times s. Okay. Well, they give us the volume of this shape, which is going to be the volume of the sphere minus the volume of the cube. And it's probably fastest to throw this into the solver. And so the volume of a sphere, which is 4/3 pi, and here's our radius that we wrote in terms of the side length, 1/2, because it's only going from here to here, times square root of 3, because the full diagonal would be square root of 3 from here to here, times the side, and then we're going to cube that minus side cubed, and we throw that into our solver. Thank you, everybody.